Welcome everyone to CPD in 43, our first March event. This month we have two events. So today we have a event from Mitek, which will be doing metal web joists and the future home standards from Peter Bullock. What we will be doing is doing a deep dive into that. Obviously, it's a 30-minute CPD. This is originally billed to be about 60 minutes, so it will be going over some matters quite swiftly, but hopefully that would be of great interest. And also as well, Peter has offered to do a separate CPD with anyone that's interested for the full length. So please do reach out to him directly. As usual, there are no CPD certificates that are issued. So if you do require one or would like one, please reach out to Peter directly, and he's offered to produce those and send those across. So I will hand it straight over to Peter, and as usual, I'll be in the background and we'll be back during the Q&A session. Thank you very much, Peter.
Right, thank you very much indeed. Can you, just wanted to make sure you guys can hear me?
That's perfect. Can you see the screen as well?
Fantastic. All right, brilliant. All right, good morning. Thank you. Sorry, good afternoon, guys. Thank you very much indeed for joining us today. As I was introed there, my name is Peter Bullock and I'm a business development manager at Mitek, or for Mitek. So yes, this is a bespoke 30-minute webinar, and it's broadly based on our REBA certified 60-minute webinar, and it's designed to give you guys a better understanding of what a posi joist is, and also what Mitek is doing as a company to address the future home standards and help you to specify Mitek posi joists as the floor joist of choice. Bit of a tongue twister. So yeah, we do have this 60-minute REBA presentation. So if you or your companies want us to do that, please do reach out at the end, and I can either email me or whatever, and we can get something organised. And also, if you do need a certificate, I'd like to provide those. So again, you'll need to email me with your details so I get those sent out. But let's crack on, because we've only got 30 minutes, and give this CPD some context. So most builders are exploring all of the different technologies that are usually and that are currently available to them to help them achieve the current and the future home standards requirements. Almost certainly, as well as making new properties more airtight, they'll have to incorporate ground source or air source heat pumps, photovoltaic cells, as well as MVHR systems to remove the stale air from within the properties. And all of this is to save energy. Now, ground source heat pumps, they need water pipes to be laid beneath the garden or have a borehole drilled, both of which for smaller properties is almost certainly not viable. So properties will need air source heat pumps or similar technologies. Now, whichever of these systems is used, services will need to run within the floor space. Then with MVHR units, that's mechanical ventilation heat recovery units, you'll need to run a whole network of ducting leading from plenums to manifolds and onto the heat exchanger. But more of that later. But before we go any further, let's have a quick digress and tell you a little bit about who Mitek are as a company. So Mitek in the UK is based at Dudley in the West Midlands. We're owned by Mitek Industries in the US, who are in turn owned by Berkshire Hathaway. So we're not just a UK or a European company, we're actually global. And we employ around 6,500 staff at the last count, of whom 2,500 are based out of our design services offices in Vietnam. So in our factory in Dudley, we take, if you can see top left picture here, we take pre-galvanized steel coil and stamp out the connector plates that are predominantly used in the manufacture of roof trusses. We have 14 150-ton power presses for this. We also have 3 200-ton power presses for stamping out the posi joist webs. The connector plates and the webs are only sold to our UK and our European network of licensed manufacturers who actually make the trusses and the posi joists. So you can be sure that any truss or posi joist you come across is a quality product. We also offer our customers a range of automation services, as we call it, which includes the supply of presses for trusses and presses for the posi joists, and single and multi-blade saws as well. The keystone to Mitek, though, is our world-class Premier design software. So posi joist manufacturers, they receive a DWG or an IFC, an industry foundation class file from the Revit architectural model and upload it into the Mitek Pamir design software. And that's to design the roof trusses and the posi joists. The design file is then sent back to the architect or back to the customer and can be uploaded back into their Revit model. The 3D image we can see on the right is of an IFC file exported from Pamir, where the posi joists and the attic roof trusses were designed and then imported into the Revit model. Our design service team here in Vietnam, they're working on Revit models and 2D drawings, also creating bill of materials and providing estimations and much more for major UK house builders and builders around the world. Right. Enough about Mitek, Lo, because we've only got 30 minutes. Enough about us. So for those of you who don't know, let's answer this question: what is a metal web joist? Now, a posi joist, which we've just been describing, can also be referred to as a metal web joist. This is like the generic name for it. And a posi V-web, the actual V-web component, can also just be called a V-web or a posi web, but basically they're all the same thing. They're all posi joists. Now, the reason that metal web joists are becoming more and more mainstream and are now the joist of choice for many builders and specifiers is that they satisfy a need. And that need is to be able to quickly and easily, and hence at low cost, run services, whether it be pipes, cables, wires, or MVHR ducting through a floor space without the need to drill holes. So that's the whole premise of metal web joist. Right, let's get back to this question. What is a metal web joist? So a metal web joist is a wall and truss constructed from stress-graded timber, most typically TR26 and the V-webs. Now, the reason that TR26 timber is used is it's the same grade of timber used in the manufacture of roof trusses, which most metal web joist manufacturers also make. And the design of the metal webs is always undertaken using the bespoke software supplied to the metal web joist and roof truss manufacturers. And it's used to calculate the optimum timber size and the position of the V-webs to withstand the requirements of the application it's been asked to do. The timber members of the metal web joist are typically sourced from managed forests with chain of custody certification. So, for example, rather than using a hefty 10-inch deep solid joist, a more eco-friendly 253 millimeter deep metal web joist can be used. The EPD statement for connector plates and posi joists can now be downloaded from our website. And the declaration is for 1 kilogram of connector plates or 1 kilogram of posi joist webs. And this would help a specifier determine the credentials of metal web joists relative to solid timber, relative to I-joists or beamer block floors. The metal web joists are covered by a European technical approval, an ETA, and are designed in accordance with EC5. So posi joists can be designed in a range of depths. The greater the depth of the joist, the further it can span. Also, the greater the depth, the greater the load it can carry. The greater the width of timber that's used in the design of the metal web joist, the greater load carrying capabilities. And the width is actually calculated using our bespoke software. But even the minimum width allows for a secure fixing of both the decking above and the plasterboard ceiling beneath. Now, the most common sizes used by house builders are the 225 millimeter 9-inch, 253 millimeter 10-inch, and the 3 or 4 millimeter 12-inch. The 3 or 4 millimeter is actually the most cost-effective metal web joist because it works better for brick coursing and its ability to accommodate even more services such as the ductwork and the pipes and the cables, etc. If the metal web joists are at 600 millimeter centers and the staircase is, for example, 900 millimeters wide, then a 2-ply metal web joist will support the load on either side with a trimmer at the stairhead. All of the hangers required are specified by our software. So within our software, we have Simpson Strong-Tie and Cullen hangers. They're in our database. So what is supplied to site are all of the metal web joists and the girders, that's the multiple joists, the hangers, the trimmers, perimeter noggins, associated Z-clips, and the strong back timbers and anchor straps. Now, most of our customers can also supply the decking boards and the default glue as well. As well as all that, you receive an A3 layout, which has a Q code in the corner, and that enables the whole system to be installed very quickly. We'll come back to Q codes later on, but it enables the whole system to be installed very quickly. All of the metal web joists are bespoke and not off the shelf. This ensures and prevents there being any materials delivered to site that are then wasted, because the metal web joists are made to measure. Calculations can and should be provided to the building designer rather than a photocopy, for example, from a book of span tables for the solid timber. So this enables steels to be correctly specified, as well as blocks and foundations to be spec'd correctly. We have a UK-wide network of over 125 licensed posi joist, posi rafter and roof truss manufacturers, from Inverness in the north to Redruth in the south, and from Pembroke Dock in the west to Canterbury in the east, and in Ireland from Craigavon in the north to Tipperary in the south. So you could choose a manufacturer close to your site or close to your offices. We supply and we have on our books, we have people like Donaldson's Timber Engineering and Crendon Timber Engineering, Pascal's Timber Engineering, DWB, people like that. We have lots of group manufacturers as well as sole traders as well. So why should you use metal web joists? Now, in this photo, there are actually 7 small bore pipes. Imagine drilling all the holes for those small bore pipes into a solid timber or I-joist and then feeding all the pipes through. You then have to drill the holes for the 4-inch saw pipe, all the while running up and down a ladder and getting sawdust in your eyes. You then find out you've actually compromised the structural integrity of the I-joist and the floor is unsafe. And that's before even trying to run the ductwork through. Once the ceiling is actually in place as well, you can still put more services through by cutting a hole and putting a fishing rod through. So it gives you that retrofit capability. These pictures are from sites where we've worked with some of the UK's biggest house builders, where MVHR was crucial to their operational carbon emissions and where I-joists would have been impractical. Note also that the hot and cold feeds have yet to be run through. Also that radiator pipes haven't been fed through, or wires and cables and waste pipes, but there's still plenty of room to run those through. Incorporating MVHR ducting into a floor system cannot be easily undertaken unless metal web joists are specified. In this photo, there are 6 ducts running into this one manifold. Another 6 have yet to be run into the manifold beyond. Imagine drilling holes for these ducts into solid timber or I-joists. It'll be a nightmare, to say the least. We all, I'm sure, by now understand how an MVHR system works. There are many tutorials that you can watch on YouTube, etc., and help you if you don't. But let's, however, run through the components of the system. So an MVHR system comprises the heat exchange that we can see top left here. This can no longer be mounted in a loft space unless it's in a controlled environment. So a lot of house builders are moving the units to be mounted under the stairs or in a utility cupboard. Solid ducting that we can solid ducting that we can see the middle one here. So the 2 square vertical ducts that we can see there are actually the attenuators or silencers, and the other 2 are for the fresh air in and for the stale air out. And then we have the manifolds top right. Typically 2, one for the stale air in and one for the fresh warmed air out. And then we have plenums and flexible ducting. So with the majority of the ducting being located in the floor space, this necessitates the use of metal web joists, because how else would you accommodate so many ducts passing through the joists? Interestingly, and also with Part M of the building regs requiring ground floor toilets to be wheelchair accessible, this means that hiding the manifolds in the floor space makes a lot more sense. It creates more square meterage of usable room space. And if the heat exchanger is located in a hall or a kitchen cupboard, the unit can be easily maintained and the filters cleaned by the homeowner. Mitek works with house builders, in this case Bellway. They approached us with one of their house types and a few requests regarding a Zender MVHR system that needed to be installed. They needed to incorporate 2 MVHR manifolds within the floor depth, plus a lot of ducting and 5 ground floor plenums. a ducting tree, I'm not sure what else to call it, a ducting tree leading to 5 more plenumas for the bedrooms, bathroom and ensuite. Zender actually admitted that the job would not have been possible without metal web joist. It highlights the fact that all of the components within a house cannot be designed individually and in isolation. They now need to be designed in an integrated way as a unit. This we are finding is one of the advantages of Revit software and also Clash technology as well. So what we're saying is that by using metal web joist, there will be fewer problems on site. Even if the original architect's drawings are not designed through Revit, we can include the MVHR ducting and components into our 3D model. An installer or contractor, by scanning a QR code which is applied with the drawings in the corner of the drawings, can download a file that is the job in a 3D format. This is unparalleled in the industry. From the 3D model, we can see the ducts. That's the sort of the bottom right one there. We can see the ducts that rise up like a tree. They've been located in a void specially created for the purpose, because as we know, space is limited in all sort of new build houses. The 3D model is a game changer for the MVHR installers as well, because they're now referencing it on their smartphones in favour actually of looking at it on the drawings, because they can spin it around and look at exactly where they need to go. What is the cost? So we now know that metal web joists will have to be used in new builds going forwards. But here you ask, what is the cost? But what do we class cost as? If we're talking about material costs, then yes, I-joists are less costly than metal web joists, but I-joists are typically made from a top and bottom rail, made from timber, and there's an OSB web. But you'll have issues in trying to run all of that ductwork with external corrugations, as we can see in the left photo there, that have corrugations on the outside. But all of those services need to pass through holes that have to be drilled through the OSB webs. And from experience, we've actually found that those corrugations actually jam on the holes of the OSB, and therefore you can't pull it through. But of course, it's not just the ducting that has to pass through the floor void. We also need to accommodate waste pipes, radiator plumbing, hot and cold water feeds, wires and cables, all that within the floor space. Those are the true build costs. With metal web joists, the build costs will be less. For Cameron Homes, we designed out 12 hangers and we saved 72 minutes of labour, as well as the huge cost of the hangers. So this was achieved by using top chord supported joists, which are unique to metal web joists, and we'll look at this detail a little bit later. All of that hidden time and cost is taken by every contractor to drill their services through the I-joist, and that's not included in the quotation for the I-joist floor. How long does it take to drill those holes? There could be as many, from our calculations and from experience, there could be as many 200 holes that need to be drilled through the I-joist, and that doesn't include the possible 50 holes that may be needed to be drilled for the I-joist to accommodate the MVHR ducting. That's a lot of up and down ladders. So as we've said, the true cost of a floor is not the delivered price as per the quotation, but the price once all the joists have been fitted. All of the trades have been in and cut and drilled their way through the I-joists. All of that time and labour is not included in the quoted price for the floor. So by specifying and using metal web joists is an ideal opportunity to save cost through materials and labour and save site callbacks due to the simplification of installing services through the webs of the metal web joists. And as we discussed earlier, the Cameron Homes floor used 12 fewer hangers. We all know from site that hangers are not always nailed correctly. Frequently, nails are not fitted into all of the holes that are required. All the incorrect nails are used. All the wrong hanger has been used. Fewer hangers equals fewer issues. When a contractor arrives on site to fit their pipes, cables or ducting, they have to refer to this or similar guides to ensure that every hole drilled is not too close together or could weaken the I-joist. Each contractor has to refer to this guide. Would it not be easier to use a metal web joist when no drilling or notching is required at all? Each contractor has to follow this guide to ensure that the I-joist floor is not condemned as being unsafe due to there being too many holes drilled too close together, although some contractors choose to ignore this guide, as we can see. Now, I'm sure, though, that there are occasions when metal web joists have been drilled, but on the installation guide, it does say, don't drill, don't notch, don't cut, and don't remove any webs. But some idiots still choose to do one or several of these. But with metal web joists, any issues that may arise on site or at a later date can be traced back to the manufacturer via the identity tag that every metal web joist and truss has. Now, if I-joist is specified for a floor and services need to pass through where the booklet of tables does not allow it, then almost certainly costly reinforcement similar to that shown will be required to strengthen the joist to allow the services to pass through in the position they're required. More importantly, the time lost to climb the ladder and measure and then drill the hole and locate first 2 reinforcing plates and hammer 60 nails into one side, then it's down the ladder, back up the other side for another 2 plates and another 16 nails. How long does that take and at what labour cost? And that time and labour cost isn't included in the price for the I-joists. And one always has to hope that the plates are fitted correctly, all nail holes are filled. Any error may require a callback to the site in the future. So we're eliminating this by using metal web joist. Also, the maximum aperture that can be created in a 12-inch deep I-joist is only 250 millimeters wide and 200 millimeters deep. So that's going to restrict the number of ducts that can be passed through the I-joist. But with metal web joist, there's no limit because you have all the V-webs all the way along the joist. So by choosing to use metal web joists, you'll find that the contractors, the electricians, the plumbers, the MVHR contractors, etc., will be able to spend less time on site and cost you less money, and should eliminate all of those callback potentials associated with I-joists. Testing of metal web joists. So the acoustic requirements specified by the NHBC for England, Wales, Northern Ireland is 40 dBs, 40 decibels. But for Scotland, it's more stringent at 43 decibels. I think they're just a bit noisier up there. Now, as we can see from this table, the 202mm 8-inch posi that were tested achieves the 40 dB rating. And as the posi joists get deeper, so the acoustic performance improves. Going to the 253mm 10-inch deep joist without quilt achieves the 40 dB rating, and this satisfies the Scottish regulations. Now, the reason that sound characteristics improve with depth is due to the top and bottom flanges being further apart and the sound having difficulty crossing the void. With solid timber and I-joists, the sound is able to pass directly through the solid. So by using metal web joists is beneficial in the reduction of sound transmissions. That's basically what we're saying. To date, Mitek has invested in 11 tests that are being carried out by independent companies to verify the fire performance of posi joist. The floors incorporating posi joist were primarily tested to EN 1365 with different joist centres, different joist depths, different decking and different ceiling makeup. They achieve either 30 minutes or 60 minutes fire resistance to satisfy the minimum provisions set out in the building regulations, approved document B, fire safety. So to get technical, even more technical, so section B3 sets out the fire safety regulations to mitigate fire spread in structures. Fire resistance is not just joist dependent, but dependent on the overall floor or wall construction. So floors in a dwelling house at height above ground up to 5 meters, they require 30 minutes fire resistance, which is REI 30. So our first column is the target resistance. And floors in blocks or flats, 60 minutes fire resistance is required, which is REI 60. The metal webs themselves are classed as non-combustible in accordance with EC decision 96/603/EC. But if specifics are required, you can download a report summary from our website. If you want a specific report, then we can email that to you. But every year, what we're saying also is that every year, Mitek invests a significant amount of money in fire tests. Safety with and compliance to codes and standards is paramount to Mitek. Also, and of interest to you guys, for inner city timber frame construction projects and in situations where timber frame is close to neighbouring properties, it's necessary to have a Category C flooring system along with a Cat C wall system. So this is the highest category of fire protection and is key during the construction phase of the build. Mitek has the only metal web joist system that has a fire safe and or fire safe plus accreditation, and that's by the Health and Safety Executive and the Structural Timber Association. On now to future homes. So embodied carbon is all about the manufacturing of goods and products and transport, etc. And this is very important and is of interest to us as a company, because by using metal web joists in favour of other flooring systems can reduce the CO2 GWP of the floor and hence improve your build. Operational carbon is to do with how efficient the house is in terms of the energy used by a family living there, and this is the carbon that the Future Home Standards refers to. Now, at this point in time, the implementation of the Future Home Standards seems to be very vague. You guys probably have a better understanding than us as to where we are on the adoption of these regulations. But the new regulations that are and will have to be incorporated into houses now has never had to be integrated into properties before. Therefore, the issues that we are highlighting in this presentation, you may well have never encountered before. We're all learning from each other as to the best way to achieve the end result, which is a reduction in operational carbon at the end of the day. As a company, we attend all of the HBF, the Home Building Federation events, and that's to keep us abreast of policies and technical developments and health and safety, etc. So we're doing everything we can to keep abreast. From experience, we've found that being able to pull, I think as we alluded to this earlier, so from experience, we've found that being able to pull semi-rigid ducting, which is what we can see here, through a metal web joist is a breeze, despite the corrugations on the outside. The installers have a coil of ducting on the floor and they just pull it through to where the plenum is. But without wishing to bash I-joists, pulling ducting through a hole that's been made through an I-joist flange is virtually impossible due to the corrugations catching on the flange. Hence, more time is spent on installing the ducting through the I-joist. And also we've found from experience that having multiple ducts running through a 225mm 9-inch posi can still be a struggle in terms of the number of ducts that are required. The deeper the joist, such as a 10-inch 253, is better and provides greater flexibility and more ability to install more duct work. But going deeper to the 12-inch to 3 or 4mm deep joist works better for all the ducting, but also works better for brick coursing. So 12-inch deep posi is what you need. Quick digress off into health and safety. So as well as reducing sawdust on site caused by drilling holes through I-joists and the need to be constantly climbing up and down ladders, not only to drill holes, but also to fit the surfaces through the holes. So by incorporating the metal web joists into cassettes before they leave the factory means that a metal web floor can be quickly and safely installed and completed on site. You have fewer guys working at site on height on site. And that's obviously beneficial for health and safety. The stairwell access is also usually not cut out prior to delivery, thus achieving a clean and clear walking surface. Alternative systems may require more operatives working at height for a greater length of time. Individual metal web joists are also lighter in weight than a solid timber for the same span and load situation, thus avoiding potential overexertion by the guys fitting the joists. And as the metal web joists that are delivered to site of the correct length, no cutting is required, which may be needed with other joist systems, which will involve circular saws and hence sawdust. If the metal web joists are being installed as individual joists, then a crash decking is usually installed beneath the joist layer. Many posi joist manufacturers also offer the customers the option of having a pre-delivery site visit, and this is just to check on spans and dimensions and hence prevent reworking or scrapping of materials once they get to site. Okay, metal web details. So there are two details here from brick and block construction. So for detached properties and to save on the cost of hangers, the joists can be built into the inner leaf of the external wall and sealed around with mastic, or they can be set into end caps again for air tightness. For terraced or semi-detached, hangers do tend to be used though. For timber frame structures, the most common metal web joist detail is the top cord support end detail. So the end of the web hooks over the wall plate and enhances the shear strength of the timber. It enables the floor to be installed far more quickly as hangers are not required to be purchased or fitted. Two more details. So we're aware that bricklayers do not always lay their blocks where they're supposed to. So we have within our software the ability to design with horns, that's the left-hand image, which can be cut off on site, giving us site tolerance, normally 10 to 15mm. The right-hand image shows a trimmable end where a greater length can be cut off if specified. Both details are available either for new build or refurbishment for brick and block or timber frame. Two robust details for flatter developments that incorporate posi joists can be downloaded from the robust details website. Either of these two details will be used in separating floors where good acoustic performance is important. The last but one slide, can you believe it? So the key source for information regarding posi joists is our website at www.mitek.co.uk, and you'll go to this page that we can see here. On our website, you go to the resources tab and click on downloads, and that'll take you to the page that you can currently see. Our fire test report is there, as well as our World of Posi Technology, our posi joist brochure, installation guide, and our EPD statement. And if you want to create or detail using posi joists, then it's now simply a case of going to the NBS National BIM Library and downloading the posi joist Revit dynamic object. And this would give you guys the ability to create a realistic posi joist within your Revit model prior to it being designed on the Pamir software. And then this, believe it or not, is actually the last slide. Now, what I will do, I'll just leave this up for a few minutes. So if you do want a certificate and would like to send your certificate out, please email me at peter.bullock@mii.com. I can then produce a bespoke certificate for you, obviously with your name, and you can put your company as well, if that's not obvious sort of from the email address. If you do have a design query, then please email ukdesign@mitek.co.uk. They can look at your drawings and say, and sort of, you can sort of say, well, you know, will this work as a 9-inch or a 10-inch, or do you need to go to 12-inch? They can look at that and ping you back. But obviously, we don't manufacture the posi joist, so if you want a quotation or your customer wants a quotation, then you need to go to one of our manufacturers that are on our website. But that is basically the end of the presentation. Thank you very much indeed, guys. Thank you for your attention. Thank you for being present today. I really do appreciate it. Thank you.
Thanks for that, Peter. We do have a few questions, so I'll just run through those, if that's okay.
No.
Hopefully you're well versed in responding to these questions. So let's see if we can trip you off with at least one.
Right.
So we've got Gary, who's asking if your company produces thermal bridging calculations to meet enhanced construction details for new build dwellings.
I must admit we don't actually have thermal calculations. We normally sort of would leave that to the specialists. What we do know is that when the posi joists are used as studs in vertical studs, there is very little thermal transmission from the inner to the outer leaf, because the only connection is this metalwork. So there is a page on our World of Posi Technology which can be downloaded from our website, and that does give you some sort of a thermal image, and there are some, I don't know if there are some calculations there. Basically, I think we've got it down to 0.11 watts per meter squared of thermal transmission between the inside and the outside. But if that is I'm not saying it's not a genuine question, but if you could email me with that question, what I can do is ping it through to our top engineer, and you know, he can come back to you, and I can link that page on the document to you.
Great. We've got a question in from David. Are there any scenarios in which you would not recommend posi joists and prefer traditional joists?
No.
or alternatives, I guess.
I suppose the only time you might want to, well, even if somebody's building an extension to a house, let's say, you know, you've got a detached or a semi, and you want to build an extension to the side, I will still recommend using posi joists, because even, let's say your existing floor is an 8-inch deep floor, the shallowest posi joist is 8 inches, you can still run 100mm soil pipe through that. So if you wanted to put a bathroom in there, you know, you can still run that through. Yes, you could use solid timber, and the plumber could come through and carve their way through it. But if you had an 8-inch deep solid timber and the plumber took 4 inches out of that because he wanted to run a soil pipe through, you're not going to have much meat left structurally. Whereas with a posi joist, you do have that designed in there. I think the beauty also is that you get these calculations, so everybody can see those calculations. Every design of posi joist has, I don't know, I think it's about 10 pages of calculations with all the different loading scenarios, etc. So you can pass it on to anybody that wants to look at it, and it all checks out.
Great. We've got a question in from Samaya. What is the maximum length of a metal web joist, and do you recommend them for any other sectors other than residential?
Oh, crikey, yes. Okay, so the manual semi-automatic strut runner, which is our sort of our bread and butter type machine, that is 15 meters long. So that, in theory, I think, to be honest though, the longest joist you can manufacture is 14 meters, and I've actually seen them being made. It was a four bearing joist, so supported at both extremes and then at 2 points in the middle. They do become quite unwieldy. So I think the typical longest joist is about 6 or 7 meters for domestic applications. They do get used for the likes of Premier Inns, or it might be travel lodges, but they do get used for those compartmental sort of holiday hotels. They get used as classroom roofs. They get used as classroom floors, office floors. They can be used as rafters as well, and they can be used as the base of a big attic roof truss. So you have a posi joist base, and then the attic constructed above it. They can be used vertically as studs, which we alluded to earlier, so that works as well. Incredibly lightweight, but it's obviously very strong. So yeah, to be honest, they can be used for virtually everything. When I say flat roofs, obviously that is, sort of a very shallow pitch. The joists tend to be flat, and then you have a furring strip on top to create the runoff. But yes, they can be used for virtually everything. Even if your customer they might say, right, I want a screed floor. You can actually put a liquid screed flow on top of the posi joists. Obviously, it has to be designed specifically for it, but there is a screed flow loading on it. Some people want to have a solid beam and block floor, and they then use posi joist in the corridors, because you then get your piping coming into the corridor and passing through to where it needs to go. So there's always an application for posi joists.
Great. Question from Stephen. You mentioned electrical cables. Do you specify and detail cable trays?
Interesting question, actually. For domestic applications, most Sparkies, most electricians, they just pull their cables through. Sometimes they will nail them to the bottom flange just with like a little sort of horseshoe clip. Sometimes they'll use a cable tie, sort of a plastic cable tie. They'll sort of bunch 2 or 3 wires together and sort of put it halfway up the sloping web, or if there's a vertical block for a strong back or something like that, they'll sometimes just nail them to the side of that. But I must admit, generally no, they're not used. Cable trays aren't used. It's another cost, and it's just something else to try. No is the answer.
Great.
Most people.
Question from Nathan. You beat me to my question around STA categories during the build. Do Mitek have options for A, B, C, and when extra measures are required for each prior to the underside of the joist being boarded?
Sorry, can you say that again? So that's to do with fire?
I believe so. So Nathan's, you beat me to the question around STA categories during build.
Right. Okay, so go on, sorry.
Sorry, I was going to say, do Mitek have options for A, B, C, and what extra measures are required for each prior to the underside of the joist being boarded?
Not sure what that's referring to. Sorry. I mean, I know most ceilings are either type A, or if it needs a higher fire resistance, you have 1 or 2 layers of type F fire line board to the underside. That's what all of our fire tests have. If it's a cat C or the C plus, the timber is pre-treated with a fire retardant. Supplementary nails are put through the webs, and then the floor is actually constructed Maybe, so I'm not quite understanding. Maybe I'm not sure who asked that question. Could you just email that question to me, and I'll again I don't want to sort of like waffle, if that makes sense. If you can just email me the question, and I will find out the answer that you're after.
Great, thank you for that. Brian, can posi Jaya joist, I presume, accommodate modest cantilevers, or does it always require integrated steel framing?
No, cantilevers can be achieved as long as they're told about it. A lot of posh houses quite often have cantilevers sort of in the hallway. Upstairs, maybe you've got sort of like a balcony area upstairs that can be cantilevered. Yes, they can be designed in. If it's an internal cantilever, yes, that can be designed in. Normally, if it's in a staircase area, then it's normally has to be pretty substantial. Those particular joists normally pretty substantial. The reason is if you have parties at Christmas, you may have 10 people upstairs looking over the balcony, singing carols or something like that. So it does normally beef things up a bit. But what you can do, of course, is you can incorporate a small steel universal joist actually within the depth of the posi joist or towards the end of the posi joist to actually, so it doesn't become a cantilever, if that makes sense. But in answer to the question, cantilevers can be created. Yes.
Great. Another one from Nathan. Do Mitek have any test evidence in collaboration with Zender or other MVHR suppliers for passive fire protection or semi-rigid ducts passing into the floor zone through the plasterboard lining?
So yes, that's a very incredibly topical question, actually. Yes. So there are certain, if you have a downlighter sticking through any floor, a lot of the downlighter companies are now including an intumescent annulus ring sort of or ring within the actual behind the lighting, so if there was to be a fire that would seal. Certain companies are also looking at building that into the actual plenum as well. If you think about the plenum, the way the plenum's designed, you have a disc typically on beneath, and then you have this annulus round it. So they're looking at including a plenum, intumescent ring into that. And in fact, I think it was 2 weeks ago now, we actually had a fire test undertaken. We're still waiting for the results actually to come through, where we actually tested we took a posi joist floor, we cut a hole in it, and we actually put a plastic bung in it, which was of the same material that the actual plenum disc is made of. So it's just like a plenum disc. And we then put it into a fire test. But interestingly, the fire test to pass, it's not just a case of preventing the fire from, if the fire breaks actually through the ceiling, that's still not a fail. It's the integrity of the floor. So if you're after a 30-minute fire test, that effectively means that after 29 minutes, somebody who's upstairs should still be able to evacuate the room. So as long as the floor itself is still walkable, can still evacuate. So so this test was carried out. As I say, we're still waiting for the results, but maybe speak to Zender. They're based in Camberley, but they're one of the top 3 MVHR manufacturers, and obviously they do all the components for the floors. But they're actually, I think they were one of the involved in this test as well.
I'm just mindful of time. We're a little bit over time, so I'm just going to say I know there's quite a few extra questions on the chat box. So what I can do is I could send all of these questions to Peter and have him respond, and potentially that could come out with the email that comes out to everyone. Or obviously, please do directly respond to Peter and ask your question. So apologies if I miss you, but I'm just going to quickly try and ask a couple of the questions that are right in front of me. So we've got one in from Michael. You mentioned crash denking. Could you elaborate on that? Do you have manufacturers in Ireland or Northern Ireland? How do you usually fire stop where the floor meets a compartment wall?
Okay, so in terms of crash decking, yes, they're in essence they sort of like they look like they're a bit like milk crates in a way. They're just like huge cubes that I think they just deliver on a lorry, and literally they fill the room with them, and literally you can actually walk on them. They're very lightweight. They're similar to sort of the boxes that you bury underground for water overflow and things like that. They're very similar, very lightweight. They stack on top of each other, and they're great. You can actually walk around them. So you, rather than just walking around the outside on scaffolding, you can actually step onto this, walk across. The thing you mustn't do is drop your tape measure, because it goes right through and you never see it again with your pencil. But yes, it is literally called crash decking. If you just search crash decking on the internet, I'm sure it comes up, and I'm sure most scaffolders, or yeah, I think they're either supplied by the scaffolders or by whoever's running the site. But every site I've been to, they've just been either orange or green in colour.
Okay.
Um,
I think we've
what's the
got
other?
time for one at least. So a question from Lee. How durable are the joists against corrosion? Has this been tested over years of use?
So the actual steel, it's pre-galv steel. It comes into our factory in huge coils, big 5-ton coils, and it's pre-galvanized. I mean, the our house was built in 1970, and we've got Mitek roof trusses in it with Mitek connector plates, and they're still they're slightly, if you touch them, they've got a sort of a little bit of white dust on them, but basically they're still good. So the life expectancy of the posi joists and of the metal web plates and the roof trusses, the life expectancy is deemed as the life of the house, basically. They're not recommended. Same with roof trusses, with connector plates. They're not recommended for coastal. I'm not sure what it's called, but if you're building a house that's on the seashore, they're not recommended for that, simply because of the corrosion from the salty air. But there's different categories for that. But yes, their life expectancy is that of the property.
Great. And I think we'll go with one last one, as it seems like it's very much on topic from what you've just answered.
Yeah.
It's from Stephen, asking about green roof loadings and whether a load of 2.16 kilonewtons can be accommodated within the posi joist system. Obviously, green roofs comes in many forms, so I'll leave you to answer it. But obviously, there's lots of different types.
Yes, I mean, basically, what you would need to do there, with, I think it was Stephen, you said, best thing you can do there is email our design office, ukdesign@mitek.co.uk. Phone them, tell them what span you need to achieve, what depth of posi joist you're looking to achieve. With that loading, and they will literally, Jazz in our design office, he'll just literally ping those into our Pamir software, and he'll sort of say, they're going to be, 400 centers, 12 inches deep, will carry that load. But obviously we need to know what the load is. If you don't know what the loading is, I'm sure you can achieve it. But from our experience, if you just say, well, if it's a standard sedum green roof, I'm sure we know what that is. But I'm guessing you guys probably know what the loading is. So if you can supply that to them, they can very, very quickly design it. What they will send back to you is an email with a profile of that joist. So you can then take that on into your designs, and then you can contact one of our manufacturers who can then actually quote you for the supply of those joists.
Perfect. Thank you so much, Peter, for that. And thank you for trying to answer as many as questions as you could possibly answer within the time given.
No,
Hopefully
no
you've
worries.
enjoyed coming along. I think it was about 120 people that ended up logging in, by the way, just to give you a
Wow.
rough idea numbers wise. Um, and it was really insightful. And thank you for keeping in such detailed information within that 30 minutes window.
It
Very
was
much
tight. It was
appreciated.
tight, wasn't it? It was tight on time. But no, really appreciate you guys actually attending. And as I say, if you do want a certificate, we'd love to give you a certificate. But you do need to email us with your name and company name, so we can put it on your certificate. That'd be brilliant. Thank you very much indeed.
Yeah,
Super.
we've popped the two pertinent emails within the chat box, so please copy and paste those across. I presume Peter will be sending across the presentation as well, so we could circulate that to all of the attendees. That's a nod, so yes. And then also as well, we'll be sending across the questions that were posed via the chat box over to Peter, but obviously please feel free to contact him directly if you have project-specific requirements or any additional pertinent question that you'd like to ask. Hopefully everyone can see on the screen we've got the entire schedule of 2025 shown. So our next one is next week, which will be fire and life safety design, fire safety in buildings from R5 Consultants. And obviously you can see the schedule for the remainder of the year also listed. Please do make a note of this. Please do add these to your calendars so you can save the date. We're already booking into 2026 as well. So I think we've got Q1 already booked. So we are looking to book Q2 to Q4 for 2026. So please do reach out to me directly and suggest any speakers or events that you think that we should add into our schedule. As always, your attendance is greatly appreciated, and I look forward to seeing you next week and for our normal monthly events.
Super, brilliant. All right, thank you very much, Osman. Thank you very much for inviting me along, and thank you
No worries.
guys for attending as well. Really appreciate it.